Hello class, welcome to Geometry Lesson 6.6, which is all about conditions of special parallelograms. By the end of this lesson, you should be able to identify rhombi, rectangles, and squares by the characteristics of their diagonals. This is really similar to what we did yesterday, so hopefully this lesson doesn't seem too difficult for you. So example 1, if we use the diagonals to identify rhombi. So information about diagonals can help to classify a parallelogram. In the parallelogram ABCD, we know that segment AC is perpendicular to segment BD. What else can we conclude about this parallelogram? So the given information, you can see I have these arrow things. So I know off the bat that I have two sets of parallel sides. And then I also know that I have a right angle inside. So there are a few things that I can conclude. Since we know that this is a parallelogram, I know information about the diagonals. I know that diagonals on a parallelogram bisect each other. So that means segment AE would be congruent to segment CE. And I know that segment BE would be congruent to segment DE. And that's just by definition of a parallelogram, because all diagonals are bisectors in parallelograms. Then when I look at the picture, I see that, hey, there's a 90-degree angle. So that means that if I look, if this is 90, this also has to be 90 because they would be supplementary, right? They form that line for the diagonal. And if the angle I just drew in was 90, that means that this other angle also has to be 90 because, again, we're forming the straight line of the diagonal. And the last one also has to be 90 degrees. So then if we know that all of the diagonals meet at a 90-degree angle or are perpendicular to each other, we can say that this parallelogram, so ABCD, is in fact a rhombus. Except I forgot to explain one other key feature of a rhombus. Do you guys know what I forgot to say about this rhombus? I forgot to mention that the four sides are congruent, and I forgot to prove how I knew that. So I'm going to back up for a minute. We ultimately do know that this is a rhombus, but I am going to back up. So if I know that this met at a 90-degree angle, and I know that these are congruent, and these are also congruent, I can actually say that I have congruent triangles because all of those meet at 90-degree angles. So I could say that triangle BEA is congruent to triangle CEB, is congruent to triangle DEC, is congruent to triangle, AED, because we have a side angle side situation going on, right? We have the diagonal, then we have the right angle, and then we have the other diagonal, like part of the diagonal. So all of those are congruent using side angle side, and if we know that those triangles are congruent, that means their corresponding parts are congruent. So that means that I could say AB is congruent to BC, is congruent to CD, is congruent to DA. Because all four of those triangles are congruent to each other, so that means those four corresponding parts are also congruent. And that's just using our CPCTC. So that's how I know it's a rhombus. I have congruent outside measures, and I also have the perpendicular angle diagonals. Okay, so if we know that angle JHK and angle GJK are complementary, what else can you conclude about GHJK? Explain. So see if you can come up with other things that would maybe be congruent and ultimately what shape it is. Good luck. All right, so for this question, hopefully you realize that this forms a rhombus and you were able to identify that, okay, if we have two sets of parallel sides for the parallelogram, we can use alternate interior angles to say that they're congruent. So we have those two congruent angles, and we already knew that angle JHK and JGK were complementary. So if I knew that, I could swap out, instead of saying JGK, I could say HJG because they're congruent using alternate interior angles. So I could say angle JHK and angle HJG are complementary. And then I can say, okay, well, if those are complementary, I know there's 180 degrees in the triangle. So if I subtract those two angles, I'm left with 90 degrees, right? So I'm saying 180 minus 90 degrees, the complementary angles. I'm left with 90 degrees. And that 90 degrees is specifically the HLJ. So then we know that is a right angle, which makes all of the diagonals perpendicular and therefore a rhombus. All right, so here are a couple of theorems. So theorem 619 is the converse of something we did yesterday. So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay? So if you have a parallelogram and you have perpendicular diagonals, you know it's a rhombus right off the bat. You don't even have to prove the opposite sides like I did in the first example. So then theorem 620 is the converse of theorem 617 from yesterday. So if a diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. So you can see that angle B was bisected here, and so was angle D. And when that happens, that's another sign that you have a rhombus. Example 2, use diagonals to identify rectangles. So Ashton measures the diagonals for his deck frame and finds that they are congruent. Will the deck be rectangular? So for this problem, if you look at the picture, you can see, first, let's figure out, is it a parallelogram? So I see that I have one set of 8-foot sides and one set of 10-foot sides. So I have two sets, or two pairs of congruent sides. So that's enough to say that it's a parallelogram. Then Ashton measured the diagonals and said that they are congruent. So if those diagonals are congruent, that is enough information to say that the figure is a rectangle. So yes, the deck will be rectangular. So just like for a rhombus, if you can prove that the diagonals are perpendicular, you get a rhombus. For a rectangle, if you can prove that the diagonals are congruent, you can say it's a rectangle. So go ahead and try question number 2. We have, if the diagonals of a quadrilateral are congruent, is the quadrilateral a rectangle? Justify your answer. Good luck. All right, hopefully for this one, you said no, and then you justified. So the reason why we can't say that the quadrilateral is a rectangle is because if the diagonals don't bisect each other, it is not a parallelogram. And if it's not a parallelogram, it can't be a rectangle. So remember, yesterday I showed you that tree with the quadrilaterals. And then we had, kites. Wow, if I could spell kites. Kites and trapezoids. And then we had parallelogram. And then I said, hey, we have rectangles. And we have rhombuses. And then from those two, we have a square. Well, we can't have a rectangle if we don't have a parallelogram. That isn't possible. So just because it's a quadrilateral does not mean that it is a parallelogram. It could be a kite, it could be a trapezoid, it could just be a four-sided figure, not even categorized as a parallelogram, kite, or trapezoid. Okay, so the answer is no. So theorem 6-21 is the converse of theorem 618 from yesterday. So in this one, we're saying if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so kind of what I just explained. Then example 3, can we conclude whether each parallelogram is a rhombus, square, or rectangle? And explain. So if we look at letter A, parallelogram ABCD, I can look at this picture and I see, okay, I have these two congruent sides, and I know if it's a parallelogram, their opposite sides are also congruent to them. So that means I have 4 congruent sides, and then I also have an angle that is bisected there. So I have an side, I have an angle, and then I have this shared side. So I could split it up into 2 triangles and say that those 2 triangles, this green one and then this purple one, these two triangles have to be congruent. And if those 2 figures are congruent, I can say that any angles are also congruent. So I can add in the information that these angles are congruent. And if we know that, that is enough information to use the theorem, which one was that? Theorem 6-20 from a couple slides ago, saying if we have opposite angles that are bisected in a parallelogram, which we have, then it is a rhombus. So I can say that this figure is a rhombus. Then, in the next example, letter B, we have parallelogram PQRS. So if I look, I see that I have diagonals that were bisected, and it looks like, okay, they all have the same measure. That means my diagonals are congruent. So that means that this is a rectangle. And then, if I look, I also have a 90-degree angle, which means that this is a rhombus. And if I know that it is a rectangle and a rhombus, that means that it is actually a square. All right, question 3 for you. Is the following parallelogram a rhombus, square, or a rectangle? Explain. Good luck. Alright, so since we knew that this is already a parallelogram, I know my diagonals get bisected, so if GL has 1 dash mark, LJ also has 1 dash mark. If HL has 1 dash mark, that means LK has 1 dash mark, which means that my diagonals are congruent. And if my diagonals are congruent, we know if diagonals are congruent in a parallelogram, we know that it is a rectangle. All right, example 4, use properties of special parallelograms. So quadrilateral STUV is a rhombus. What are the values of x and y? So you can see y is at the top. Remember, if we have a rhombus, our angles get cut in half by the diagonals. So I can say 65 minus y would equal 5y plus 5, and I can solve from there. And then I can say 4x plus 3 equals 5x minus 10, because that angle would also get cut in half. So then if I solve for this, I can add y to both sides, and I would have 65 equals 6y plus 5. Subtract 5 from both sides, I have 60 equals 6y. Divide both sides by 6, and I have 10 equals y, or I can say y equals 10. Then if I want to solve for x, I can subtract 4x from both sides, and I'm left with x minus 10. I can add 10 to both sides, and I get 13 equals x, or I can say x equals 13. And that is how I would solve that problem. Why don't you go ahead and figure out if we have a parallelogram ABCD, and we know that AC equals 3W minus 1 and BD equals 2 times the quantity of W plus 6. What must be true for ABCD in order to be a rectangle? So basically, what does W have to equal in order to make this a rectangle? Good luck. Hopefully for this problem you ended up with W equals 13. If you have questions, please be sure to reach out for help. One thing I do want to point out to you before I move on is make sure when you are naming parallelograms, so when you draw those pictures, you need to keep those letters in the same order. So if I start here and then I go here, I have to put letter C here. Some of you like to switch these two around, but you need to keep them in order. So if it's the figures called ABCD, you have to do A, B, C, D. If you change it, this would actually be A, B, D, C. Okay, so make sure that you're careful when you are labeling figures. All right, so then this last example, we have a group of friends set up a kickball field with bases that are 60 feet apart. How can they verify that the field is a square? Well, right off the bat, we can say, okay, all of the opposite sides are congruent. That means that it's a parallelogram. And since all of the sides are congruent, the parallelogram is a rhombus. So if they want to know if their field is a square, we already know it's a parallelogram and a rhombus, so we need to prove that it's a rectangle. And the way that we prove rectangles is to prove the diagonals are congruent. So if they measure from, this would be second base to home plate, and they measure from first base to third base, if those two diagonals are congruent, that means that it is also a rectangle. And if it's also a rectangle, then it would be a rhombus. So in order to verify the field is a square, they need to measure the distance between home plate and second base and first base and third base to show that they are equal. Go ahead and take a look at this figure and see, is MNPQ a rhombus? Good luck. Hopefully you said yes, and you looked at the picture and you saw, okay, the diagonals bisect each other, so it is a parallelogram. And then if you solved for this angle in here, you would see that it is 90 degrees, because if we do 180 minus 32 minus 58, you're left with 90. And that means that our diagonals also are perpendicular because they meet at 90-degree angles. And if they meet at 90-degree angles, that means that it is a rhombus. All right, and our last slide is just the concept summary of everything from today's lesson, focusing on the diagonals in these special parallelograms. If you have any questions at all, please be sure to reach out for some help, and I'd be more than happy to help you. Have a great day.